How's it going, ladies and gentlemen? Mr. Donahue here again. This time we're going to take a look at some second row diatomic molecular orbital practice problems. Quite the mouthful. Number one, based on the molecular orbital theory, is fluorine gas F2 paramagnetic or diamagnetic? Explain. So let's take a look at fluorine. We know fluorine has a electron configuration of 1s2, 2s2, 2p5. Right, so we're going to focus on the 2p5 electrons. So we got 1, 2, 3, 4, 5 atomic electrons, and then same thing over here, 1, 2, 3, 4, 5. And when we make our molecular orbitals, we end up with the sigma 2p. We end up with the pi 2p, we end up with the anti-pi 2p and the anti-sigma 2p molecular orbitals. So now we got to fill in all these electrons. We have a total of 10, right? We have 5 from one of the fluorines, 2p's, and another 5 from the other fluorine. So let's fill them in. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when we fill in the molecular orbitals, you can see that all of them are paired up. So if every electron is paired, that tells you that it is diamagnetic. So is it paramagnetic or diamagnetic? It is diamagnetic because all of the electrons are paired up in those molecular orbitals. Number two, based on the molecular orbital theory, is oxygen gas, O2, paramagnetic or diamagnetic? And it's the same kind of process. Instead, we got 1s2, 2s2, 2p4 for oxygen. So in the 2p's, we got 1, 2, 3, 4 electrons. And then since it's O2, the other oxygen is going to look identical. So we have a total of 8 valence electrons that we have to place into these molecular orbitals, right? So we got the sigma 2p, we got the pi 2p molecular orbitals, we got the anti-pi 2p molecular orbitals, as well as the anti-sigma 2p. So let's start filling in the electrons. We got 1, 2, 3, 4, 5, 6, 7, 8. All right, well, if we take a look, we have some unpaired electrons in those molecular orbitals. So we have a paramagnetic molecule because of the unpaired molecular orbital electrons. Number three, based on molecular orbital theory, how many unpaired electrons are there in OF plus ion? So again, oxygen, we got the 2p4, and for the fluorine, we got the 2p5. This plus tells me that we got to lose 1 electron. So it doesn't really matter where you lose it from. So let's just draw it. 1, 2, 3, 4. Fluorine, we should have 5. 1, 2, 3, 4, 5. And then just remember that this plus is there. So let's fill in. We have a total of, 3, 4 plus 5. We got 9 electrons minus 1. So we go 1, 2, 3, 4, 5, 6, 7, 8. And then we would have a 9th, but that plus 1 charge tells me it's not there. So how many unpaired electrons are in OF plus? We got 2 unpaired electrons in that molecular orbital diagram. And I think that's it. I hope you found that helpful. I'll see you in class. Okay, bye.